Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from a domain of functions, right? And in this class, we'll find out the domain of this function f of x, which is the sum of two functions. In the first function, we have the logarithmic function, and in the second function, we have inverse trigonometric functions. So we'll see how we can find out the domain of a function which is a sum of two or more functions, right? So let us see how the concept of intersection of domains helps us to get the domain of this function f of x. So let us first assume this function as say g of x and this function as say h of x. So we have two functions. So g of x is given by 1 over logarithm of 1 minus x to the base 10, and h of x is inverse sine function of 1 minus x. So we'll separately find out the domain of these two functions, and the domain of this function f of x is the intersection of the domains of these two functions. So let us take the domain of this function as dg, and here the domain of this function as dh, right? And if the domain of this function f of x is taken as df, then the domain df is given by the intersection of these two sets, that is dg intersection dh. So this intersection, it implies that we have to take only the common values of x which satisfies both these functions simultaneously, right? And we have to discard all those values of x which makes either this function undefined or this function undefined, right? So let us first find out the domain of this function, that is g of x. So here we see that in the denominator we have logarithm of 1 minus x to the base 10, right? And we know that the logarithms of negative quantities are not defined in the set of real numbers. So the first condition is that this term, that is 1 minus x, it should be greater than 0, right? And moreover, here 1 minus x should not be equal to 0. It implies that x should not be equal to 1, right? So we have to discard x is equal to 1, because in that case it becomes 1 minus 1 0, and logarithm of 0 is not defined, right? So here we have 1 minus x should be greater than 0, because here 1 minus x should be a positive quantity, right? So solving this inequality will get minus x greater than minus 1, taking 1 to the right hand side and then multiplying both sides by negative 1. So here we have x and here we have 1, and the direction of the inequality, it gets reversed, right? So x should be less than 1. So here we see that we have the conditions, that is x should not be equal to 1 and x should be less than 1. And here there is one more condition which is required, and which makes this function g of x undefined, that is x should not be equal to 0, because when x is equal to 0 we have 1 over log of 1 to the base 10, and log of 1 to the base 10 is 0. So we have 1 over 0 which is not defined, right? So now we have these three conditions. So now let us represent the these three conditions on the real number line. So here we have the real number line, and we have here a 0, and here we have 1. Right now, we have just seen that x should not be equal to 1, right? Because when x is equal to 1, we have 1 minus 1 0, and log of 0 is not defined. So here we will not consider this 1. Now, similarly, here x should not be equal to 0, so we'll not consider x is equal to 0. And here we have x less than 1, right? So it means we have this interval that is from minus infinity to 1, and discarding these two values, that is x is equal to 0 and x is equal to 1. So now the domain of this function g of x can be written as dg is given by the interval. First we go from minus infinity to a 0. So here a 0 is not included, and then we take the union because x is less than 1, so we have to go up to 1, right? And then we write here 0 to 1, and both these points are also not included. So this is the domain of this function g of x. Now let us find out the domain of h of x. So here we have the inverse sine function, and we know from the theory of inverse trigonometric functions, that is sine inverse theta has the principal branch from minus pi by 2 to pi by 2, and provided this theta it belongs to the interval that is minus 1 to 1. So here if we take this quantity, that is 1 minus x, as theta, then we have sine inverse theta, and theta belongs to this interval. So we can now write theta that is greater than or equal to minus 1, and here we have less than or equal to 1. Taking theta is equal to 1 minus x, we have this inequality, and now we can easily solve this linear inequality by multiplying throughout by a negative 1. So here we have positive 1, the direction of the inequality get reversed. Here we have minus 1 plus x, then here we have minus 1. Now adding 1 throughout, we have here 1 plus 1, and here we have minus 1 plus x plus 1, and here we have minus 1 plus 1, right? So here we have 2, and here we have x, and here we have 0. So we have now x greater than or equal to 0 but less than or equal to 2, right? So the domain of this function h of x is given by this interval, that is x belonging to the closed interval 0 comma 2. So here 0 and 2 both are included. So let us now represent this domain on this real number line. So now here we have 2, and 2 is included, right? And we go from 0 to 2. So let us draw it over here. So this is the domain of this function h of x. So we write dh is equal to the interval that is 0 comma 2. And remember here 0 and 2 both are included, right? So here we have 0, and here we have 2. So now let us write the domain of the function f as df, and dg is given by minus infinity to 0. Union, here we have 0 to 1, and then we have the intersection, and here we have 0 comma 2, right? So now here we have to take the intersection of these two sets, right? And from this real number line we can easily conclude the domain of the function f. Right, now see here the common region is given by only 0 to 1. Right, now see, because here we have minus infinity to 1, and then here we have 0 to 2. So only this portion is common to both the domains. But here we have to note that this 0 is not included in the domain of g of x, but 0 is included in the domain of h of x. So we have to discard this 0. Right, and similarly 1 is included in the domain of h of x, but it is not included in the domain of g of x. So we have to also discard 1. So we have to take only those values of x which lies in the interval that is from 0 to 1, and it is open from both the ends. So we can now write the domain of the function as the set from 0 to 1. And remember, 0 and 1 are not included. Right, and all the values of x which lies between 0 and 1, it falls under the domain of the function f of x. So we can also write this set as x greater than 0 but less than 1. So this is the required domain of this function f of x, which is the intersection of the domains of these two functions.